Hello, I'm Alex and welcome to Module 7 of Fabric Fundamentals. Today we're going to be discussing data warehouses. Now, the common question that I get asked is what's the difference between a lakehouse and a warehouse? Because the lakehouse has got a very similar experience with its SQL endpoint. If it's Spark, you want to go lakehouse. If it's T-SQL, you want to stick with the warehouse. If you need multi-table transactions, you're going to go with the warehouse. And your data complexity. Do you know what it is? If not, you want to go lakehouse. If it's structured or unstructured, lakehouse again. But if it's structured, stick with the warehouse. So let's go through some theory and then I'll take you through an exercise. So data warehouse, to build a modern data warehouse, we've got data ingestion. So we need to move the data from source systems into the warehouse. Data storage, where we're going to store in a format that's optimized for analytics. Processing, for transforming data into a format that's ready for analytical tools. And analysis and delivery, we want to analyze data to gain insights and deliver those insights to the business. The warehouse experience is a relational, fully managed, scalable, and highly available data warehouse. It supports full transactional T-SQL, and it can be used to store and query data in the lakehouse. Users can create tables, load, transform, query data, all with T-SQL commands. It supports both SQL for analyzing and querying and Spark for processing and machine learning. It enables collaboration between engineers and analysts in the same environment. The data engineers build a relational layer on the lakehouse data, and analysts can use T-SQL and Power BI to explore and analyze the data. A dimensional modeling structure tables into it structures your tables into fact tables and dimension tables. Dimension tables should include a surrogate key, which is unique, a system generated identifier for each row, and an alternate key, a natural business key from the source system, like a product code. Both keys are needed for consistency and traceability. Special dimension types, we've got time dimension, which enables aggregation over time periods, year, month, day, and slowly changing dimensions, which tracks the changes of the attributes over time. Slowly changing dimensions. Now, there may be questions about types that pop up in the DP 700. The ones that I've seen, it tends to be asking a question about type 2. So type 0, no changes allowed, the data stays fixed. Type 1 overwrites old values, so we don't keep the history there. Type 2 is the main one, and that adds a new row for each change, and the full history is tracked. Type 3 adds a new column for the previous value, tracks only the last change, and Type 4 uses separate tables for current and historical data. And here's some schema designs. So we have a star schema where the fact table is at the center and it's directly linked to dimension tables, and it's denormalized for query efficiency. The snowflake schema, dimension tables are normalized into related subtables, like splitting product into category and supplier tables. So you have the lakehouse versus the warehouse. Fabric Lakehouse acts like a database over a data lake with files, folders, tables, and shortcuts. It supports big data processing via Spark and SQL engines, and it provides ACID transactions. The Fabric Data Warehouse adds a relational layer on top of Lakehouse data for SQL-based analytics. It enables T-SQL for querying, DML operations, and modeling with table views, and it supports integration with reporting tools like Power BI. The storage, we've got various ingestion methods that can be used: pipelines, data flows, cross-database querying, and the copy into command. Table cloning, we've got zero copy clones save storage by referencing the same data files in OneLake. And use cases for development testing, data recovery, and historical reporting. And the command is create table as clone of. Some things we want to consider. We've got staging table usage. That's used for temporary data storage during loading. enable data cleansing, transformation, and validations, and they support loading from multiple sources into a single destination. Data loading process in Fabric. Use T-SQL to load the data from files into staging tables, typically done as batch process, daily, weekly, or monthly. And Lakehouse integration. No need to copy data from Lakehouse to Warehouse. Use cross-database querying to access Lakehouse data directly from the warehouse, but it's read-only. The recommended load sequence. Ingest data into the data lake with the optional preload transformations. Load files into staging tables in the data warehouse. Load dimension tables. Update the existing rows or insert new ones. Generate surrogate keys as needed. Load fact tables. Use surrogate keys to link to dimensions. And post-load optimization. Update indexes and distribution statistics. SQL Query Editor offers features like IntelliSense, code completion, syntax highlighting, and client-side validation. It's a familiar interface of users of SSMS or Azure Data Studio. Use the new SQL Query button to start. And an example use case, we can create views for Power BI reporting. We've got the Visual Query Editor as well. It's similar to the Power Query Online. Use the new Visual Query button to begin and drag tables onto the canvas to start building queries. Use the Transform menu or the plus button to add columns, apply filters, and perform transformations. And as you'll have seen in a previous video on Data Flows Gen 2, this is all backed with Copilot now, so natural language can be used. Semantic models. The semantic model overview, we define relationships, aggregation rules, and calculations and measures, and it's used to create reports in Power BI. Views in Fabric. The data view shows the tables in the semantic model. The query view displays the SQL queries used to build the model, and the model view visualizes relationships and measures. Building a semantic model. To create relationships, we use click and drag in the model view to link tables, connect the fact tables to dimension tables. We can create measures there. Use the new measure button in the model view. Measures are calculated using DAX and useful for metrics like month-over-month sales. We can also hide fields that we don't want our users to see. We can simplify reporting by hiding those tables and columns, and the hidden fields remain usable in the semantic model, so you can hide things like your SysID that's used for the relationship. Visualize the data by using the new report button, and we can create Power BI reports directly in the warehouse. It enables exploration of query results or full warehouse data, opens Power BI service for report building and sharing. And we can secure our warehouse with the following security features. Role-based access control, which we can control the access to the warehouse and its data. TLS encryption, secure communication between warehouse and client apps. Azure Storage Service encryption, which protects data in transit and at rest. Azure Monitor and Log Analytics, track the activity and audits access. And MFA, multi-factor authentication, which adds extra security to user accounts. And Microsoft ID, Entra ID integration, manages user identities and access. Workspace versus item permissions. So workspace permissions, the data is organized into workspaces to manage access and lifecycle. Workspace roles are the first layer of security. An admin has full control over the workspace, can manage the roles, settings, and all content, and can delete the workspace. A member can create, edit, and delete content, and can add other members. A contributor can create and edit the content, but cannot delete content or manage workspace settings. And a viewer has read-only access, can view reports, dashboards, and datasets, but cannot create or edit anything. Item level permissions. We can allow read to access the SQL connection. Read data allows reading from tables or views, and read all allows access to raw Parquet files in OneLake. To monitor the warehouse, we can use dynamic management views or DMVs for live query insights. And we have some code there that we can use. I'll just leave that on for a second. And next up, we're going to go onto the exercise where we'll create a warehouse, and I'll show you around what we can do there. Okay, so as always, I'm going to put the link to the exercise in the description, so follow along, get used to using warehouses. So from within our workspace, we're going to go to new item, and I'm going to go to warehouse. We'll just name this something identifiable. Right, I had an error message there because I hadn't resumed my capacity. I've got a capacity in the background that I use for these kind of projects, and it is good practice to pause that so you don't waste your Azure credits when you're just practicing. Right, so now that that's started, I've created the warehouse, and we're going to just jump straight in with a new SQL query, and we're copying this from the exercise. So I'll paste that and run, and this is going to create our product table. And there you can see we've got a new product table. If we click that, okay, so we've got the schema, right? So the schema is all set up, and next we want to add some data. So this will be a new query. And if we run this, we might need a refresh. And there you go, we've inserted some data, right? So the next thing that we want to do is they give us a link to a lot of data. So we're just going to open this. Copy all of that and pop it into a new SQL query. Now this will take about 30 seconds to load, so I'll just pause that. Okay, so that's finished, and it's created new tables, customer, date, and fact sales. So now we want to start querying this data, and we've got a query here that we're just going to add. And here we have added the date dimensions so that we've aggregated across year and month. And in the next one, we are going to add region into that query as well. Okay, so you can see very quickly we've inserted data, we've queried it in several ways. The next thing we want to do is create a view, which we could use for Power BI reporting. Let's go new query there, and we just want to create this view. So now that that is created, and we can check the views folder down here, and we can see our V sales by region. If we were to click that, we can see exactly what we've saved. But we want to add another query where we're just looking at that view. And there we go, can bring in that data there. Next is a visual query. So let's go to drop down here and go to new visual query. And we want to drag on the fact sales order. And there we go. We've got a preview of our table underneath. and we also want the dim product in the query. Now, if we click the plus icon on the fact sales order, we get a few options here, and we want to merge these two tables. Right, so merge queries. And if we pick the dim product, we need the dim product and the product key. And we want the product key from the first table. And we'll leave that as a left outer join. And there we go. We've got the tables merged, and we just need to expand that. So if we expand, we can bring in the product name from the dim product table into the fact sales order. And there you go. So we now have data from the two tables in one, in just a visual experience. So zero code again to get that outcome. Next, while we're here, we'll take a look at defining a data model. So we'll build a semantic model with the data that we've just brought in, and it's as easy as going to new semantic model, and we can select all of the tables here. Name the semantic model, so we'll call it sales, and you can select different workspaces, but we want to create it in this test workspace. Once that loads, it'll give us a familiar looking experience, and we'll just be able to drag the columns to create the relationships required, and then we can just visualize the data from there. Right, let's bring our fact sales order here, and we are going to build a very quick star schema. From the fact sales order, we're going to do product key to dim product. And sales order date key to date key. Customer key to customer key. Right, so that's all of our relationships defined, and from the side here, we could create the measures that we need. We could add the DAX that we need, or we can go on the top toolbar and add new measures, new tables, calculation groups, parameters, everything that we're used to seeing. From here, it's as easy as creating a new report, and this will load up all of our data. From there, we will just add a quick bar chart, and then we can do the month name and the quantity. And there you go. So as easy as that, in just a couple of minutes, we've created tables, we've queried the tables, we've created views, we have created a semantic model, and we've built a Power BI report to distribute to the business. So I hope that's been beneficial. Please give it a thumbs up if it has. Comment below if I've missed anything. And also in the next module, we're going to be doing real-time intelligence. Really important. Every business wants this right now. So not to be missed. Subscribe so that you get notified of that video.